So how does this apply to chemical reactions? Well, let's redraw what we had above in another way. And now it looks largely like a chemical equation. We've got our starting materials, our starting ingredients on the left side, and our product, or the item we're trying to make, on the right side. The amounts of each of the ingredients that we needed, those are what we needed to make a balanced equation. Those are our coefficients. And so once we put this in a similar way with chemical equations, we should see that this is very, very much the same. So when we apply this to chemical equations, we're generally going to go through the following steps. First, always balance the equation. Second, find the moles of the reactant. You'll use those moles of the reactant to find moles of product. And then you can convert that to grams of product. Sometimes you might need to go the other direction. You're given an amount of product, you need to figure out the starting material. You just work through these steps backwards. So you will again always balance the equation first, but then you'll take the grams of product, go to moles of product to moles of reactant to grams of reactant. So these equations should always look like grams to moles, back to grams. And so the first and third step, grams to moles, moles to grams, we should be pretty comfortable with. Only that middle step is new. But that middle step is why we did the part with the food, because it's really the same calculation we just did. So let's look at the following equation. Potassium plus oxygen reacts to form potassium oxide. And I want to know if we have 2 grams of potassium, how much potassium oxide can we form? So where do we start? What's the first thing we need to do here? We need to balance our equation. So we've done that now. Now our first step below is going to be to find the moles of potassium. So we balanced. Now we need moles of potassium. Well, we know how to do that. We take the mass of potassium, 2 grams, and we divide by the molar mass of potassium. 1 mole over 39.1 grams is 0.0512 moles. All right, we're going to use that now to find moles of the product. Now, what's our relationship there? Well, just like in the bagels example, we used the numbers. We're going to do the same thing here. Remember, that's what these numbers mean. 4 moles of potassium reacts with 1 mole of oxygen to form 2 moles of potassium oxide. So we take our moles of potassium and we use our coefficients as a conversion factor. So moles of potassium oxide goes on top, moles of potassium on the bottom. That way our units cancel. And we get our moles of product. So our last step finally is to find the moles of product. I'm sorry, not the moles of product, that's what we just did, but the mass of product. And this just becomes a grams to moles conversion. So we take our moles that we found in the last step, 0.0256 moles potassium oxide, and we multiply by the molar mass, which we can calculate as 94.2 grams per 1 mole. Tells us that we need 2.41 grams of potassium oxide, or we will make 2.41 grams of potassium oxide.